Hi everyone, this is Brett Sanders, and in this PRIMo tutorial, I'm going to cover how to configure input files to simulate spatially and time-varying precipitation. Earlier simulations involving precipitation that I've shown in these tutorials have all involved a spatially uniform and temporally constant rainfall rate. That is how the initial input files had been set up. So typically the input files have involved a constant precipitation rate. So options precip is set to 0, precipitation depth of some amount, often 100 millimeters, and a time scale for that precipitation of 60 minutes, which worked out to be a rate of 10 centimeters per hour. And when all the boundaries are set to walls and all the options are turned off, and we simulate PRIMo, we get a depiction of ponding on the land surface shown here. And this is the depiction of the solution on the coarse grid. So now we'd like to imagine the possibility that we're not using a constant rainfall, but some spatially and temporally varying rainfall. In order to get that rainfall data, you would want to go to a source of precipitation data, such as a source from NOAA or the Weather Service or other data sources that would give you gridded output files, raster formatted, spatially distributed rainfall information for different time instances. And you need to create really a set of raster layers showing the spatial distribution of flooding at different times. So in this video, what I'm going to show is how PRIMo is configured to input files like these and how to set up files like these so they're in a format that PRIMo can read and successfully use. So what I'm going to do first is turn your attention to a script which is located inside the directory of files that is available with the PRIMo zip file, and you'll find that there is a file called make precip input file Miami Gate. So this is a MATLAB script that I configured to create hypothetical rainfall data that could be used as input into a PRIMo simulation. What's most valuable about this script is that it shows the formatting of data that PRIMo will need in order to successfully input this spatially and temporally varying input data. This script does not show where to get real input data, but if you did get real input data, real precipitation data, you could then load those files into this script and then reformat the data in the format that PRIMo will need. So this script is designed to generate a set of precipitation raster input files. They're files of the FLT type, which are binary, simple binary files. In this case, the file root is set to Miami Gate because we're going to create these files for the Miami Gate test case. I'm going to load some information about the Miami Gate test problem, such as the lower left-hand corner and the number of rows, number of columns, things like that. So I'm going to go ahead and load that information. And in this test case, I'm going to create my own synthetic rainfall data, which just happens to have the same number of rows and columns as the PRIMo grid has. But in general, that's not necessary. The grid used for precipitation can have its own lower left-hand corner, its own cell size, and it should simply just be written in the same coordinate system that's used in PRIMo. So if PRIMo is running simulations with a coordinate system where the x-axis corresponds to longitude and the y-axis corresponds to latitude, then you want to have a raster file in the format of latitude and longitude. If you're using a projected coordinate system where you have eastings in meters and northings in meters, then you'd want to have your raster, your precipitation data in that same format. Okay, so what this initial text does is simply configure the size of a raster grid based on some familiar information, such as the grid that's already being used for Miami-Gate, but that's not necessary. That's not a requirement. I create some vectors to plot the precipitation data, and then I write a header file, which is called the precip.hdr file, which will be located in a subdirectory called precip. And inside that header file, I'll have the number of columns, the number of rows, the lower left-hand corner, XLL corner, the YLL corner, the cell size, and the no data value. Okay, so all that's going to be written to a file that will be saved. And so this will be the header information for the precipitation grid, which is used. And I'll just reiterate, this grid does not need to be the same as a PRIMo grid, but it does need to fully span the PRIMo domain. If your precipitation grid does not cover the model domain, you're not going to have any precipitation information in areas where you need it. Okay. The next thing this script does is says that I'm going to consider 16 different time levels, all spaced 7.5 minutes apart. And I'm going to assume that there's some storm cell intensity of 100 millimeters per hour. What I'm going to do here is create a set of raster files of precipitation at different time that show the bands of rainfall moving in the westerly direction to the west. Okay, I'm going to do that by creating different rainfall intensities every 7.5 minutes. And I'm going to do that with a grid here, which has 15, looks like it has 15, oh, that's a different, these are just parameters that are used to create my storm cell. So there's some commands here, a loop, where I loop over time, and I'm imagining that there is a band of moisture that's moving to the west. And so every time step I have a different spatial distribution of rainfall. And then once I create that matrix P of rainfall rates, it gets written to a file for that particular time step. So why don't we take a look now, when we run this script, what the rainfall looks like. As you saw, there were bands of information moving from the right to the left. So that yellow bar that you saw is the area of intense precipitation, and that's just moving to the west. So we're going to simulate flooding from this storm that brings a band of moisture moving to the left. And what the loop does is cycle through 16 times to create these 16 different instances of rainfall falling in different locations. And if we go to the Miami-Gate directory, what you'll see is that this script created a set of precipitation files numbered 0, 1 through 16, which has the precipitation amount for each of those time intervals. So you'll notice I said precipitation amount. What needs to be inside these files is a precipitation depth corresponding to the time interval being used. In this case, we're using a time interval of 7.5 minutes. So what this information needs to be is precipitation depth in millimeters for a 7.5 minute duration. And going back to the script here, I have the units of the storm intensity labeled as millimeters per hour. And you'll notice that P is taking that millimeters per hour, multiplying by 7.5 minutes, and then converting minutes to hours so that the dimensions of hours cancel, and what we're left with is something with dimensions of millimeters. So we have a precipitation depth that corresponds to millimeters. So recapping, this script here is a script that was made to create hypothetical rainfall data that covers the area of interest. In general, the precipitation grid does not need to align with the PRIMo grid, but it does need to fully span it. So you want to make sure it's large enough to fully span the area of interest. Typically, precipitation information is much more coarse, maybe resolution of kilometers or tens of kilometers that you have information. And so the grid may be much coarser and the grids may be much smaller file sizes too, because the information is just not fine resolution. So what you want to do if you were going to find your own source of precipitation data is you'd want to import those precipitation files here, create a grid where you want to write this information to files, create a header that captures the dimensions and the size of that grid, and then write each of the precipitation depths out into an FLT type file so that PRIMo can read it, and make sure that your file naming follows this convention where the 0 corresponds to the initial time, 1 is in this case 7.5 minutes later, and 2 is 15 minutes later, and then so on and so forth. So now we're going to transition into how the input files need to be configured in order for PRIMo to understand this and use this information. So this is the basic PRIMo input file. Right as of now, we have wall boundary conditions. As I mentioned before, this scenario we just looked at was just a constant spatially uniform rainfall, and so options precip was set to 0. Now what we want to do is turn this to a 1 and say we are now interested in loading the raster files of precipitation. And now this number, which is the precipitation depth, will no longer be used. So that number becomes irrelevant, but this number is still important. This number tells PRIMo what is the time interval between subsequent precipitation raster files. So that number was 7.5 minutes in the test case I just showed you. So I'm going to change that to 7.5. So now we've told PRIMo that instead of using a constant rainfall rate, use these raster files. We created those raster files, placed them in this directory. So now, assuming that each of those files was saved, or that file was saved, then we can rerun PRIMo. So it's /bin/PRIMo-GPU, then the name of the project, Miami Gate. So the model's now running along. It'll take a few moments to complete, but not too long. We can open up our MATLAB script and get ready to do the visualization. So now if we go back to our visualization script and we load those model results in, we can play it. Now what you can see is that the flooding is progressing from the east to the west as the simulation proceeds. And you'll notice that after 1 hour, only half the domain has been covered in floodwater. That's how far the rainfall had progressed over a 1 hour simulation period. Clearly, if we wanted to see something a bit further, we could increase this, say, to 2 hours, and maybe keep this at 306 every 6 minutes. And in fact, it might be even more interesting to do something where we say the results every 7.5 minutes. So say we change this to 450 seconds. So now we'll run it 2 hours, saving every 450 seconds. Go ahead and let that run, we might want to ask, well, how many time steps are we going to have over that period of time? So it's going to be 16 different time steps. So when we get to the Primo viz, we want to change this to 16. We're going to have 16 time steps that we've saved. And so now we should see the impacts of this full like pass of the rainfall going from east to west across the whole domain. We should see the implications of that in this simulation. So we'll go back to the Primo viz Miami and wait for this to finish. Okay, so we're done there. That model completed. Run the visualization. So now we have flooding progressing from east to west and covers the whole area of interest. So that is an introduction to setting up raster files for spatially and temporally varying precipitation. And there is one additional script inside of the initial installation package, which is called make precip input file 2. The difference here is that I have a spatially uniform rainfall rate that varies with time. So the logic here might be slightly easier to follow than the logic of the previous script, where I had a lot of statements to try to create that band of moisture that moves east to west across the domain. In this case, I just create something that's spatially uniform. So it's another example. But to do a practical application, these commands here need to be replaced with commands that load an actual precipitation raster from some other source into MATLAB, and then using some sort of loading that in and then writing it out as an FLT file. All right, hope that is helpful.